Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today we'll start new chapter which is about system construction and implementation. The objectives of this chapter are to first of all explain the purpose of construction and implementation phases in the system development life cycle. Describe the system construction and implementation phases in terms of your information building blocks. Describe the system construction and implementation phases in terms of major tasks, roles, inputs and outputs, and explain several application, program and system tests. We'll talk about different type of tests. Although the scope of the course does not allow to have a detailed discussion on testing, uh, we discuss these things in much more detail in software quality assurance course, but here from system development life cycle perspective, we'll discuss briefly the importance and the types of different tests in the information system. And we'll also talk about different system conversion strategies. One of the challenges in system development is to convert from old to the new system. We'll see what are different strategies and what are pros and cons of each one of those strategies. So first of all, first thing first, what is system construction and implementation? By construction we mean the development, installation and testing of system components. So now we have a detailed physical design available. Now the system will be developed, installed and tested. Every component will be developed, installed and tested. For every component, the development, installation and testing means different things. For example, if we talk about network component, then the development, installation and testing means that you put all the devices in place, you establish connectivity between them by putting all the cables, the devices, hubs, routers, the clients, servers and so on and so forth. And then you test it whether all the components, all the hardware is connected properly or not. If we talk about database, the development, installation and testing means that now you implement the schema that you have designed in the previous phase. Now you use the selected database management system and you actually execute all the queries. The data definition language, we use data definition language DDL to create a structure of the database in the system. Similarly, another component is your software. So now here the development means to write the source code in the selected integrated development environment by using the selected language. Let's say you have chosen Java and NetBeans as the IDE. So now you will write the program, you will install it on the machines and you will test it by using different techniques. We'll talk about a black box and white box testing inshallah in software quality assurance course. So this is done for the software component, right? I hope you understand that there are many components in the information system and for each component the development, installation and testing means different thing. So now at the end of construction phase, every component is completely developed, installed and tested. Now it is ready to be used by the users, right? Sometimes the people mistakenly use the term system development, okay, but it is not the right term. Development means the entire development process starting from here. If you look at this diagram, you have been seeing this diagram in all the chapters. So development means starting from scope definition, problem analysis, requirement analysis, all the way till system operation and maintenance. Sometimes the people call this construction as development or implementation, but this is not the right terminology. Similarly, the implementation means the installation and delivery of the entire system into production. So now the system is implemented. Again, many times by implementation, thus people mean construction, but actually implementation means that now the system is ready for day-to-day operation for the user. It has been implemented successfully in the client side, and now the clients can start using it. Implementation does not mean development, installation, and testing, right? Like in our graduation project also, we call it project implementation, which means the system construction. Actually, it is a wrong term, right? So this is the context of system construction and implementation. If you recall, in SAD1, we had started from scope definition phase, then problem analysis, requirement analysis, logical design, and decision analysis. In SAD2, so far, our focus has been on physical design and integration, right? So now, once the physical design is complete, we will have the physical design specification. This is the main output of this phase. We may have any design prototypes, and we may have any redesigned business processes, plus the documentation that is generated during this phase, right? So these are the inputs for construction and testing phase. In the construction and testing, we will construct and test all components of the system. The documentation will be stored in the central repository, and it should result in a functional system. And also the training manuals are generated during this phase. And in installation and delivery, it will take functional system and training manuals as input, and it will create an operational system with post-audit review, and the documentation, related documentation, will be stored in the centralized repository. And the next is the last phase in SDLC, system operation and maintenance. Inshallah, we'll talk about it in the next chapter. So let's talk about the construction and testing, and then we'll talk about installation and delivery. So let's see the tasks for completing construction phase. The first task is build and test networks. The task takes the design specifications as the input, okay, and of course the approval to continue the project after design phase from the steering committee, and it will deliver an installed network, okay. How the installed network is based on network design specifications and network details that have been sorted out in the previous phases, and they are stored in the repository. So build and test network, mostly nowadays whenever we develop a new system, the network is already available, but if some enhancements are required, they will be made before doing anything else. This is mostly the first step in the construction phase. The second step, build and test database. So now we will take the database schema from the repository, okay, and we will take sample data from the production database. So from the existing system, existing database, we will take the sample data to implement this schema that we have taken, to develop the schema, to test it, and if some changes are made, the revised database schema will be stored in the repository, and at the end of this phase, when we have successful test of the database schema, we will have a new structure in the new database, right? So build and test database will take the database schema from the repository. It will take the sample data from the production database, the existing data, test it, remove any errors, make the changes, store them in the repository, and the new structure will be created in the new database. The third task in this phase is install and test new software packages. We have discussed in the previous chapters also that there are two types of software in the organization. Some of the packages, they are purchased from the vendors, the technology industry, you can see here. So this task applies to the purchased software, the commercial off-the-shelf solution. We have talked about them, COTS, commercial off-the-shelf systems. So we get the software packages and documentation from the technology industry. Okay, these packages are stored in the software library. Okay, and any integration requirements and program documentation, they are stored in the repository. And if we have modified software specification or new integration requirements for in-house developed systems or the other programs, they will also be stored in the repository, right? So this phase will take the ready-made software packages from the technology industry. It will store them in the software library, and any changes required for the other systems will be stored in the repository, right? Maybe certain things cannot be changed in these purchased packages, but we need to consider these limitations or these new requirements for the other systems that are going to be developed in-house or purchased. The fourth step is write and test new program. So now here, this is for in-house developed programs that we are going to write by using any programming language. Let's say Java, .NET, C#, VB.NET, or PHP, whatever programming languages we have selected. So now we will write these programs and we will test these programs, right? So technical design statement, plan for program, and test data will be taken. This is an input to this task. And what are the outputs? Also, we may have any reusable components, software components that we may reuse from the software library. These are the inputs, and the outputs, it will generate new programs and reusable software components. All the new programs that are developed, they'll be stored in the software library, and the program documentation, it will be stored in the repository. And at the end, this phase will deliver a functional system to the steering body for its approval, right? So as we discussed before, first of all, we build and test network. Okay, we have discussed the details. The roles of different people are also given here. We build and test the database. Okay, we implement the database schema, we test with a sample data, and we deliver unpopulated database structure. What does it mean? It means that the database structure is there, but there is no data for the tables at this stage. For example, let's say I have products table. Okay, so let's say I have a products table. So here in this table we have product ID. Let's say we have product description. Okay, let's say we have universal product code, UPC. Let's say we have price. Okay, and so on and so forth, right? So at the end of this phase, we will have this table developed in the database, but we will not have any information about a particular product. There is no product information, there is no records in at this stage, right? This is called unpopulated database. Unpopulated, right? We have the structure, but we do not have any records. There are no records at this stage. Okay, there are no records. Okay, so this stage will deliver unpopulated database structure, right? The role of system users is provide and approve test data. Database designer and programmer will build the tables, views, store procedures. Database administrator will fine-tune the database for optimum performance using the guidelines to ensure a high performance of the database. Although we cannot change the internal algorithms in a DBMS, but we can use some guidelines, some best practices to optimize the performance of the database, and it is a responsibility of DB administrator. He will also take care of security, backup and recovery. The analyst makes sure that the business requirements, they are completely fulfilled, they are not compromised, and he will help all the other stakeholders. Install and test new software. As we discussed before, if system require purchased or leased software, or what we also call COTS, commercial off-the-shelf solution. We also call it COTS, commercial off-the-shelf solution. So they must be installed and tested. The role of analyst is to clarify business requirement. The designer will clarify integration requirement. Network administrator will install these purchase packages. The vendor or consultant from whom we have bought the system, they will help in the installation and testing phase, and the application programmer will test according to the integration requirements, because this purchased system has to integrate with the other systems. So we need to make sure that this system works smoothly with the other systems. Next, write and test new programs. Now this is about the in-house programs that will be developed in-house. We reuse any available software components in the library. Maybe we have an old system and some software components can be reused. We write new components, we test them, we document them. We have talked in detail about the components in chapter number 12, right? I hope you can recall. We have talked about the components and what is the design philosophy behind the components, the reuse, we have talked about cohesion, coupling, all those aspects, right? So I hope you can recall those. So here we will reuse any components and we will develop new components in this phase. The role of analyst is to clarify business requirement. The designer will clarify program design and integration requirements, and application programmer, mostly it is a team of programmers. They will write and test the software by using the programming language and integrated development environment that we have selected in the decision analysis phase. Now, one of the very important thing in the system development is testing. There are a lot of tests developed. There are many kinds of tests that are performed on the system and different components. We'll talk in detail about testing in software quality assurance course, but here let's have a quick look at what are different types of tests and what is the purpose of each test. The first test is a step test. It is a test performed on a subset of a program in which individual event or modules of a program are tested. It is testing of an isolated subset of a program. This is the lowest level of testing in which the individual events or the individual functional requirements Okay, individual functional requirements or individual events in a module, they are tested, right? We'll see example in the next slide and it will become more clear. Unit or program test, a test performed on an entire program. In every program we have many events, many functional requirements. So at this stage, all the events and modules are tested as an integrated unit. It is like a subsystem. Here, individual events in every subsystem. Here, all the events together as a unit or a subsystem. The system test, it is a test performed on an entire system. It ensures that application programs written and tested in isolation work properly when integrated into the total system. Let's see a simple example to clarify what is the purpose of stub test, unit test, and a system test. Okay, here is a simple example of, let's say, KFU information system. This system has many subsystems. Let's say course registration is one subsystem, library is another subsystem, exams is another subsystem, accounts is another subsystem, and so on and so forth. So we have many subsystems, right? This is the program, this is the entire system. These are, you can also call them units or you can call them subsystems, right? Let me write it here. These are units or you can call them subsystems. So all of these are subsystems. Course registration is a subsystem or a unit, library, exams, and accounts. Now every subsystem has many individual events. For example, course registration system has register course event, drop course is another event, view registration is another event, view available courses is another event, and so on and so forth. Alhamdulillah. Similarly, library is another unit or a subsystem, and the events in this subsystem are add new book, update book information, issue a book, view catalog, and so on and so forth. Similarly, exam system will have its own events, account system will have its own events, and so on and so forth, right? So first of all, the stub test. Stub test will test the individual events in isolation. I'll repeat, the individual events in isolation without regard to the other events. For example, register course, it will be tested as an individual event. Are we able to register a course or not? Drop course, if I want to drop a course, can I drop a course? View registrations, view available courses. So each event is tested individually without regard to the other events, right? So although these events, they depend on each other, like for registering course, you need to see the available courses first, right? So for registering course, you will see the available courses and then you can register. Similarly, you cannot drop a course until and unless you have registered a course. Similarly, view registration, it depends on registered course event. You cannot view registrations if we have not registered any course. But these dependencies are not tested at this level. In stub test, we test individual events like here, add new book, update book information, issue book, view catalog, and so on and so forth. Okay. Similarly, this event, all the events, they are tested in isolation. Okay, they are tested without regard to their dependencies. So this was stub test. Second, unit or program test. It is a test performed on an entire program in which all the events or modules are tested as an integrated unit. So now this entire subsystem, all these events, they have dependencies on each other. So now we will also test those dependencies. We will test this entire subsystem as a whole, in which the different dependencies of the events will also be tested. Similarly, in the library subsystem, this entire subsystem will be tested as a whole unit. Similarly, accounts, all these events, they will be tested as a complete unit or a complete program, right? Okay. So in unit test, all the units are tested together. Okay. All the events in the units, they are tested together as a complete unit. And the last one, as we saw in the previous slide, the system test, it is a test performed on an entire system. Now, all these subsystems also have a relationship with each other. Like exam, it will have some link with the course registration system. Similarly, accounts may have a link with library or labs or HR or employees or so on and so forth, right? So all these subsystems, they also have some relationship between each other. So now at this level, all the subsystems are tested together to, to consider all dependencies of the subsystems among each other. So the entire system is tested as a single unit. The entire system is tested in which all the dependencies of subsystems will also be considered, right? So these are three levels of testing: step test, the unit test, and the system test. Okay, let's move forward. The second topic of today is the implementation phase. These are the tasks for implementation phase in the system development life cycle. Let me zoom it in. The first task in the implementation phase is to conduct system test. There's a lot of testing done, and previously it was in lab testing, but now here it is the customer side testing. Here the customers or the end users, they are involved. Okay, they are involved in the test, and they will make sure that the system is free of any mistakes from the end user point of view, right? So in conduct system test phase, we take software packages, custom built programs, and existing programs. All the programs are taken from the software library. System test data is taken from the repository. The testing is performed, and if any program fails a test, the required modifications to the program, they are stored in the repository, and we may go back to the design phase or the development phase, okay, to fix these problems. Okay, it will keep repeating, okay, till all the systems have passed this test. So when there is successful system test, we will move to the next phase, which is to prepare a conversion plan. So based on the design specifications and the requirements, we will prepare a conversion plan, and it will be stored in the repository. It will not be executed at this phase. It will be executed here, okay, at the last phase. But here we just prepare a conversion plan. Next, we install the database. So now we have seen in the previous phase, the system development and testing, that the database is unpopulated. Now here, at this task, the database is populated. So now we take the database schema, we take the existing data from the production database and we convert it into the new database. We may have to restructure the existing data, okay? And now the data is migrated to the new database. So now the database will be loaded. It will be populated with the data. We'll talk about it in the coming slides, inshallah. Next, we need to train the system users on the new system. So we take the appropriate documentation and user training and documentation are shared with the steering committee, steering body. We train the system user. We need to free up their time. We need to use the training manuals that we have developed in the previous phase and we'll train the users. And now here in this phase, convert to the new system, we carry out the conversion plan that we have prepared in 7.2. We will convert to the new system and now we will have an operational system which is used by the people on a daily basis, right? So let's see details. First of all, we conduct system test, okay? We test network, database, purchase software, new in-house developed software, existing software packages to make sure that it all works together, right? So the role of system analyst is to develop the test data, communicate problem and issues with the concerned stakeholders. The system builders, database, network and programmers, they will resolve these problems. The owners and users, they will verify whether or not the system operates correctly, and it may result in return to the construction phase or even the design phase. We will keep repeating this till the system has passed all the tests. Now prepare a conversion plan. We plan for how to convert from old to the new system. Mostly it is a challenging task. We have an old system and we want to convert it to a new system. There are many things that we need to take care of, like how to install and populate the database. Okay, so taking the data from old to the new database is a challenging task. How to train the users? We need to train the users. We need to finalize the documentation, all the user manuals, help manuals, the documentation of the system and so on and so forth. And we have different conversion issues and different ways of converting to the new system. We'll see shortly. Role of system analyst or project manager is to develop a detailed conversion plan, and the steering committee will approve this plan and timetable because the users need to be freed from their work. So we need to make a plan and a timetable of giving training to the users. Now talking about system conversion, there are different strategies to convert from old to the new system. Okay. Here in all these diagrams, we have 4 strategies: abrupt cutover, parallel conversion, location conversion, and stage conversion. And in all of these diagrams, this light color represents the old system and the dark color represents the new system, right? So this is old system and this is new system. The light is old and the dark is new. Now, how does abrupt cutover works? This is the date, okay? So till a particular date, we keep using the old system, okay? And from the next day, we suddenly switch to the new system. Let's say till 31st December 2019, we are using old system, and from 1st January 2020, we will start using the new system. So it is called abrupt cut over. Abruptly, we change to the new system abruptly, right? Well, this strategy is a very risky strategy and we rarely use it, Okay, we can use it in combination with other strategies. We'll talk about it when we talk about the next strategies. But as a single strategy alone, we rarely use this strategy. It is not advised to use abrupt cutover. Why? Because this is the most risky strategy. Okay? You see, till a particular date, we are using the old system, and from the next day, we start using the new system. And if this new system has some big major bugs or errors or any major problem, the entire work of the company will be compromised, right? So we do not use this strategy. It is very risky strategy. We do not use it. We only use it if we are forced to use it. Why will we be forced to use this strategy? To answer this question, let me take you back to, I believe, the first or second week of your System Analysis and Design 1. At that time, you have discussed the sources of information system projects, right? I'm sure you can recall, you have talked about sources of IS projects. Okay? What are different sources? There are three sources that you have studied at that time. First is problem. The second is opportunity. And the third is, if you recall, third is directive. I hope you can recall. Okay? I'll not discuss these two. For us, the important thing is directive, right? So, directive is when any authority, internal or external, they give a directive to have a new system. They kind of force a new system. They ask the company to have a new system. Okay? For example, let's say the banks. Now, probably you guys are too young, you have not seen the old age, like 20-25 years ago. All the banks, they did not have the online banking systems. But let's say the government, they make a plan of digitizing the economy and they give a directive to all the banks that you must have an online banking system by a certain date. Okay? So let's say they gave a directive that till 30th June 2020, every bank should have an online banking system. Let's say the banks do not have banking system, online systems, and the government gives a directive that every bank should have an information system ready on this date. Now, every bank will try to make sure that the system is ready a few months before this deadline. But if it was not developed, if they could not complete the development till that time, although the authorities are relaxed, they keep delaying, they give more deadlines, but let's say there is no other option. If you do not have a new system on this date, you will have huge penalties or you will have to close your organization. So if this is the case, then only then we will go for abrupt cutover. Now we do not have any other option. We could just develop the system, we could complete the development of a new system or just on that date, and now we do not have any option, so we are forced to use the abrupt cutover, right? So this is a risky strategy. It is not advisable, it is not advised, but we'll use it if we are forced to use it. But everything has some advantages also. The advantage of abrupt cutover is that it is the most economical strategy. The cost of this strategy is minimal. It is most economical strategy. Okay. Why it is economical? When we discuss parallel conversion, it will make clear for you, right? So let's go to parallel conversion. In parallel conversion, as you can see that this is old system and this is new system, and for some time period, this time period, it can be 2 months, 3 months, 6 months, depending on the requirement and available time. For some time period, we are using both old and new system. Both these systems are used for certain time period, and this time period gives a chance to the organization to identify and remove all the bugs in the system, in the new system. And once the new system is ready and we are sure that there are no bugs in the system, then we will start using the new system completely. Okay, so for certain time period, both old and new systems are used together. So the disadvantage of this strategy is that for this time period, whatever it is, 2, 3, 6 months, the overall performance of the organization will be reduced because the workers are working on two systems. Let's say previously we were using manual system, okay, and now we have an information system. Okay, now we have information system. So the people are maintaining the papers and they are also working on computers. Okay, so every work takes more time, so it is more costly. Okay, the cost is increased because for this time period the overall performance of the organization will be reduced. And now if I take you back to abrupt cutover, there is no such cost in this strategy. We just abruptly move to the new system. So the people are using either the manual system or the information system, right? So in parallel conversion, we use some time to identify all the bugs in the system and remove them. And then once we are completely satisfied, we switch to the new system. Next is location conversion. Before moving to the location conversion, by the way, uh, uh, let's move to the location conversion. Uh, Location conversion considers many locations in the system, right, in the business. Let's say an organization has offices in many locations. Let's say, for example, Riyadh Bank. They have a branch in Al Ahsa. They have a branch in, let's say, Makkatul Mukarramah, in Madinatul Munawwara, in Riyadh, in Jeddah, and so on and so forth. Many locations. So what we do, we take first location and we convert it to the new system. Okay, here this light and the dark color, they represent the locations. Okay, so in one location we are using the new system, and in all the other locations we are using the old system. After some time we take another location and now we are using the new system in two locations and we are using old system in the other locations. After some time we take another location and we change it to the new system till all the locations have moved to the new system. You get it? Let me repeat. Here sorry, the ink is not erasing. Okay. Here this light and dark color, they represent the locations. So we start from the smallest location and we change the system to the new system. All the other locations are still using the old system. Then we take another location, we convert it to the new system, and we keep doing this location wise till all the locations will have new system. Okay? So the advantage of this strategy is that, again, usually we will start from the smallest location with the minimum load. So it gives us a chance to identify and remove the bugs, and the old locations, their work will not be compromised. They are still using the old system, and step by step all the locations will move to the new system, right? And what is the disadvantage? The disadvantage is that if the locations also need to talk to each other, the locations also need to work together. In some location there is old system, and in some location there is new system being used. So it will be hard to make the communication possible between different locations, right? So different locations are using, some of them they are using old system, some are using new system. So if they have to exchange some information or have to integrate together, it will be more challenging. And one thing more, that we can also mix the strategies. What do I mean by that? I mean that in the first location, we may use parallel conversion strategy. So in first location, for some time period, we use both old and new systems. Once we have identified all the bugs and removed them, now we can move to the new system completely. Let's say in the second location also, we use the same strategy. We use parallel conversion. For some time period, we are using both old and new system, and after that, we move to the new system. But let's say from the third or fourth location, now we are confident that we have removed all the bugs. So now we may use abrupt cutover as the conversion strategy, right? So we can mix and merge different strategies together, okay? To be safe, in the first one or few locations, we may use parallel conversion, and to minimize the cost, we may use abrupt cutover in the other locations once we are confident that all the bugs have been removed from the system. Next is staged conversion, okay, strategy. Let's see how it works. This strategy works if we have used some kind of incremental development approach, okay, incremental development approach or iterative development approach, okay. All of you have studied in SAD1 that incremental approach, it will deliver some system in every iteration, in every increment, okay. So what we do here, these are different versions of the system, okay. Let me take you back to this slide. Let's say here we discussed, let's say this is the system we are talking about. Let's say the first iteration delivers course registration subsystem. After 2 or 3 months, a library system is developed. After that, exam system. After that, accounts, and so on and so forth. So what we do, first of all, we convert course registration system to the new system, okay. So here this represents course registration system. We change course registration to the new system. For all the other modules or all the other subsystems, we are still using the old system. Let's say the second, it was library, okay, second was library. Now in the next iteration we deliver a library subsystem, and now this is changed to the new system. All the other systems are same. Next, account subsystem. Let's say admission and registration. Let's say laboratories, and so on and so forth, right? So here, the different versions or different subsystems of the system are changed to new system, right? Now, talking about disadvantages, again the disadvantage is the same as location conversion. Here, the different subsystems also need to integrate together. So if some systems are using old technologies and some systems are using new technologies, it will be hard for them to talk to each other. Here also some systems are old, some are new, some are old, some are new. Till here all the systems are new. So all the problems should be resolved. But during this time, transition period, the there is a mix of systems in the organization. Some systems are old, some are new, so we may have problems in the systems talking to each other. And again, we can also mix stage conversion with location conversion, parallel conversion, and abrupt cutover, as we saw in the previous case. Let's say for the first subsystem, we pick one location, we use parallel conversion strategy, and then we keep doing this till all the locations, and in the last few, let's say, we use abrupt cutover. Okay, and similarly we take another subsystem, we use different locations, parallel and abrupt cutover strategy. So we can also mix the different strategies together to minimize the cost and time and the inconvenience for the users, right? So uh, from the practical perspective, of course, you need to consider the type of the organization, the types of the users, the distribution of the organization. Let's say if we have all the system in one place, we cannot use location conversion. Okay, so considering all the requirements, we will develop a strategy whether we are going to use abrupt cutover, parallel conversions, location, or stage conversion. So we will prepare a plan. Here we are talking about preparing the conversion plan. We will prepare a conversion plan. We will select a strategy, and it is not executed now. It will be executed in the last phase of implementation. Next is system acceptance test. As I had said in the beginning, that this test is done by the users. So this is a test performed on the final system wherein users conduct a verification, validation, and audit test. We use real data over an extended time period. So we have real users, we have real data, extensive test that addresses verification testing, validation testing, and audit testing. So in verification testing, it runs the system in a simulated environment using simulated data, right? So it is not the real environment, the actual work of the system, but it is a simulated work environment, and the data is also simulated. We try to use realistic data, but it is not the actual data in the system. It is also called alpha testing. We use simulated environment using simulated data. We check for error and omission regarding end use and design specification, because the users are concerned from the user perspective, so they are more concerned about the design, about the end use of the system. Next, the validation test runs the system in a live environment and real data. So now we use a live environment, we use real data, and of course the users are also real, so we call it beta testing, and it will test system performance, it will test peak workload, human engineering, methods, procedures, backup, recovery, because it is a real environment with real users and real data. So all the aspects and non-functional requirements of the system will also be tested. And finally, the audit testing certifies that the system is free of errors and is ready to be placed into operation. So now the users verify that they are completely satisfied and system can be put into operation. Next, installing the database, we populate the new database with the existing data from the old system. Generally, you have to restructure the data as it is populated. Restructuring may mean different things. Let me give you some examples. At a minimum, the restructuring may mean some attribute restructuring. For example, let's say in the old system, we had only one field, name. Okay? And in the new database schema, we have first name, we have middle name, and we have last name. Okay? So we need, when we migrate the data from old schema to the new schema, we need to divide this one attribute into three attributes, or it may be the other way around. Maybe in the old system we had these three attributes and now we have one attribute. So it is a very simple example of restructuring, or the restructuring can be completely new entities with new attributes, a completely new design. Anyway, so if we have to restructure, so many times the application programmers, they will write special programs to extract data from the existing database and populate the new database. So we need to understand the old schema and the new schema, and we write special wrapper programs that will pull the data from the old database and push it to the new database schema. The system analyst and designer will calculate the database size and estimate time for installation. I hope you can recall in the database design chapter we had discussed how we can estimate the database size and also the time for installation. Once we have got the size and we also know about our hardware capacity, how much, what is the read write speed of the devices that we are using, we can merge these statistics to calculate how much time will be required to migrate the old database to the new database system, right? We need to train the users. It's the second last step. The system users are trained and provided with documentation. The system analyst will plan the training, conduct the training, will develop the documentation, and help the users in learning process. So all the users need to be trained to make sure that before the system is put into operation, they know how to use the system. System owner approve release time for the users for training. The users will attend the training and they are supposed to accept the new system. This is an outline for a training manual. And the last thing is to convert to the new system. Now the ownership is transferred from analysts and builders to the end users. It becomes a functional system. So the system analyst and project manager will carry out the conversion plan, the plan that we have made previously, whether we are going to use abrupt cutover, parallel conversions, location or stage conversion, the plan that we have made here. This plan will be executed. Correct any shortcomings, the user feedback is incorporated, and we constantly conduct system surveys, the user satisfaction surveys to measure their acceptance. We get feedback from owners and the users to make enhancements in the system and to make sure that it completely fulfills all their requirements, right? So that is the end of the chapter. See you in the next lecture in the next week. Till then, Assalamu alaikum wa rahmatullahi wa barakatuh.